if you still remember back in the Laplace system, alright, the step input is simply anything that is from 0 onwards, the whole signal is on. Alright, anything that is behind or that is negative, they are simply 0. Alright, they are simply zeros. So up till when it reaches this particular 0, alright, actually zoom out, and for the rest of the signals 1, 2, 3, for the time domain, right, they always go towards this side. Right, so in other words, the step input is actually existing in the real axis. Alright, in the positive axis, but the negative axis, they don't exist, right? And therefore same thing applies for our unit step for Z transform. Alright, for the negative side are all 0 up till when it reaches here, it zoom out and then it starts, and then the signal all the way goes on. Alright, and we denote the unit step function as capital UK. I just denote as this U, and unlike this U is because this one denotes output. If you still remember, E is equals to input. So I just don't want to confuse things in terms of things like this. Alright, therefore the UK, unit step input, is when 1, where K is equals to 0, 1, 2, theta. I mean infinity. Alright, so what we have is just this, right? So when K is equals to 0, which is 0, 1, 2, alright, all the way to infinity, you have a signal of 1. Other than that, if it's minus 1, minus 2, and minus infinity, which is all this negative side, are all just simply 0. Alright, this is a flag signal. Alright, so how do we do this now? So therefore, in the Laplace domain, alright, we have this thing that transform 1, alright, to 1 over s. Alright, now same thing, if we can actually transform 1 from the using z transform to get z over z minus 1. Okay, how do we do this? Instead of from minus infinity to infinity for our functions, alright, just now is the general one, I'll just start from 0 to infinity, alright, from k is equals to 0 to infinity. It's because we aren't much cared about the rest, right, because these negative sides are all zeros. Why would I care, right? Therefore, let's start. So when I sub in k is equals to 0, I'll have just simply z minus 0 is equals to 1. Alright, so 1 times 1, because this is the 1 over here, I have 1 here. So if I just simply sub in minus 1 now, or I have 1 times z minus 1, because this is 1 times z minus 1 in this case, then I'm just simply talking about this thing, z minus 1, and then z minus 2, etc. It's the same plot again, plotting a series. Alright, and this series can be re-represented in terms of a Taylor series if I never remember wrongly. The Taylor series somewhat states that from summation of a certain 1 plus a plus a square plus a cube, so on and so forth, will give you 1 over 1 minus a. Alright, so currently what we have now is similar to that, right? 1 plus a and then 1 plus z minus 1, z minus 2 is somewhat the form of a series. Alright, so how do we do this? Alright, so I just simply write that. Okay, so I can simply rewrite as, instead of a in this case, alright, I can have this one over here, 1z minus 1. Alright, so in fact, this so-called just write this whole thing as a. Alright, because if 1 plus a plus a square, something like that, although this is minus 2, but in terms of, similarity in there, alright, I'll not prove to you the similarity, but at least you see something, right? So I can simply rewrite this whole thing as 1 over 1 minus z minus 1, right? Because this whole thing is just simply a. Okay, you can actually write this whole chunk over here as summation of ak. Alright, so you can actually no need to write this, it's the same thing, alright, but I just want to show you only. So therefore you can also rewrite our stuff of summation from k equals to 0 of z minus k. So summation of z minus k is the same thing. So this z minus k is our a in this case, alright, some sort of it. Alright, I don't know whether you find it familiar or similarity, but anyway, so if I assume that this is a, now then I'll just simply rewrite this as 1 over 1 minus a, right? And because I kind of feel that this is not cool, right, because it's not nice, right, and I can rewrite as 1 over 1 minus 1 over z, alright, and I can rearrange by multiplying z over z, because it's just 1, so I'm just simply rearranging. So what I will have is z times 1, alright, is equals to z, and then z times this one over here, I'll have z, and then z times so minus z over z, I have 1 over here. Alright, so at the end of the day, I will have z over z minus 1. Reflects the first part of our video, right? I just show you that we're gonna derive this. It's the same thing, right? But you have to put in a certain initial condition, alright? Because like a region of convergence, if you remember, what it means is that if your denominator over here is 0, anything divided by 0 is infinity. Alright, if you're talking about z transform, alright, in this case of this one, alright, the region of convergence ensuring that everything should be safe is such that z has to be equals to 1, or somewhat z has to be not equals to 1 but rather than smaller than 1, alright, or somewhat larger than 1. If you were to ask me why must z be larger than 1, alright, I'll just derive for you because it's kind of quick also. It's because if you still remember, when we sub in 1 over 1 minus a as 1 over 1 minus z minus 1, this is our so-called the characteristic equations, or the general formula, alright. So whatever thing that makes this 0 will becomes infinity, alright. So if that's the case happen, then 1 has to be equals to 1 over z in this case, alright, or maybe so-called because z to the power minus 1 is 1 over z, right? So if anything that make this becomes 0, then this means that this is unstable, alright. So try to keep it within 1, alright, because if you still remember the unit circle of 1, some sort of the meaning, so try to keep it within something that is so smaller than 1. So anything this is smaller than 1, right? So if I were to bring this inequality up, I'll have z, or in other words, I'll have become here, yeah, correct. So I'll just bring this up only, the inequality didn't change at all, alright. So z must be larger than 1, alright, and therefore that's just the case, because once we rearrange over here, it's the same thing, so z must be larger than 1. Hope that this is pretty clear. It's just saying the same thing. This thing, once you change into this form, is exactly the same thing. They are the same, alright. But the inequality, because we gotta change the inequality for this one into this one. So therefore, with this arrangement, like I use this step to become this one. So I use this step to become this one, which is this one over here for our case over here. Hope that this is clear. Or in other words, I use this first step to become the second step, alright. So I use same thing, I use this first step over here to become the second step, alright, which is this part over here, which is also the same as this lah, alright. So I hope that everything is clear. Next video we'll talk about the exponential so-called input, alright, and we see how things goes. I shall see you there.